A search is begun for a buoy that has become detached from its mooring at sea. The area to be searched is a circle of radius 30 kilometers from the last known position K of the buoy. The search area is divided into 6 equal sectors indicated by the letters A, B, C, D, E and F. Fishing boats search the triangular area KAB. We want to find angle BKA. So the vertex of, or corner of the angle is at this letter here. So BK is one arm, KA is the other arm. So we want this angle here. We have 6 equal sectors. So an angle, the angle in a full circle, 360 degrees, is divided by 6. So this angle is 360 divided by 6, which is 60 degrees. Next, we want the area of that triangle. So we use the fact that if we have two sides of a triangle, let's suppose the sides are small a and small b, and the angle in between, which is capital C actually, because this side would be small c, and capital C is opposite small c. Okay, if we have two sides of a triangle and the angle in between, the area is given by half the product of the two sides by the sine of the angle in between the two sides. So we just need the two sides and the angle in between. Well, we are given the radius of this circle. So this side is 30, this side here is 30. So we need half the product of the two sides. Half times 30 times 30 times the sine of the angle in between the two sides. So we have half times 30 times 30 times sine 60, which is 389.7 kilometers squared. Next, we want the area of the triangle KAB as a percentage of the area of the sector KAB. Well, the sector involves the circular arc from A to B, of course. So we need to consider the area of the full circle, which is pi r squared, pi times 30 squared, and get 1/6 of it to get the area of the sector KAB. You can see that the area of the triangle is going to be a large percentage of the area of the sector, of course. So here's the area of the sector, 1/6 of the full circle, where the radius is 30. And we take the previous result, the area of the triangle, and divide by the area of the sector. We get this fraction as a percentage by multiplying by 100. Next, we use the cosine rule to find the length of AB. So we want the distance from point A to point B in this triangle. Okay, so in this triangle we have two sides and the angle in between. So we want to find this remaining side. We label that a side that we are looking for small a, whether we use the sine rule or the cosine rule. If this is small a, this is capital A. Small b and c are the two sides that we are given. It doesn't matter, of course, which is b and c. Okay, so b and c just label the two sides that we are given. Okay, we can find a using this rule here called the cosine rule. So we take the sum of the squares of the two given sides minus twice the product of them times the cos of the angle in between them. So if you calculate that, you get a squared is 900. The square root of 900 is 30 kilometers. So we found that this side here is 30. So this is an equilateral triangle. Of course, we could have figured that out without doing or using the cosine rule. Okay, because this angle is 60 degrees. These two sides are the same. So we have an isosceles triangle. At the very least, we have an isosceles triangle. Because the two sides are the same, which means that the corresponding angles, the angles opposite these two sides, must be the same. So these two angles must be the same. But these two angles must add up to 120 degrees, because 120 plus 60 is 180. So not only are these two angles the same, but they must equal 60 degrees. And if the three angles are the same, then the three sides are the same, because we could look at these two sides, they're equal. Well, we find that this angle equals this angle, so the sides opposite these angles are the same. So this side must equal this side here, if we consider these two sides. Okay, so this must be 30. A helicopter took part in the search. The helicopter flew from the point F around the perimeter of the search area. So the perimeter is a full circle, and circumference of a full circle is 2 pi r, 2 times pi times the radius. So the helicopter flew from the point F all the way around and back to the point F. It then flew in a straight line from F to D and from D to C. Okay, so there's the path of the helicopter. Let's look at angle FDC. FD is one arm, DC is the other arm, so the angle is at the point D. Now this angle is known as the angle in a semicircle. It's a right angle, it's 90 degrees. Okay, because this line here passes through the center. This line is the diameter of the circle. As a matter of fact, this angle is half of this angle here. So both of these angles stand on this arc. So this result is just a corollary of the theorem that states that the angle at the center is twice the angle at the circle. Both angles stand on the same arc. It just happens that the angle at the center here is 180 degrees and it's twice this angle, so this one must be 90. So if you pick any point here and join it to the ends of the diameter, you'll have a right angle. The helicopter flew at a speed of 80 kilometers per hour. How long did it take to fly from F to D and on to C? Okay, so let's get this distance, F to D. Well, probably the easiest way to do this is to recognize the fact that FD is a side of a right angle triangle, and we know two sides of this right angle triangle. The distance of F to D is the diameter, which is twice the radius. The diameter is 60 kilometers. What about the distance of D to C? Well, we've already established that that's 30. Okay, we saw that each of these triangles, these dotted triangles, is an equilateral triangle of side 30. So we have two sides of a right angle triangle. We just use Pythagoras Theorem to find the missing side. So what do? The square, the hypotenuse, 60 squared, is the sum of the squares of the other two sides. So this side here is the square root of the hypotenuse squared minus the other short side squared. Okay. If you work that out, you get 51.96. If you check this, if you square 51.96, square 30, add squares together, you should get 60 squared, which is 3,600. So that's one way of doing it. Another way of doing it is to work with this angle. We know what this angle is. It's part of the dotted triangle. It's 60 degrees. So we want a side opposite 60 degrees in this right angle triangle. So, you know, you could use the fact that the cos of 60 is... Well, actually, we don't use the cos of 60. Cos of 60 is adjacent over hypotenuse. We need to bring in the side that we're looking for, so we use the sine of 60. So we could say that the sine of 60 is opposite over the hypotenuse. Okay, so here we have it. Sine of 60 degrees is the side opposite 60 degrees, FD, divided by the hypotenuse, the longest side of the right angle triangle, which is 60. And all we have to do then is just multiply both sides by 60. So distance between F and D is 60 sine 60, and that's going to be 51.96. So that's another way that we could do it. There is yet another way. If we look at this triangle here, okay, each of these angles is 60 degrees, so the total angle is 120 degrees. We could use the cosine rule. This distance is 30, this distance here is 30. So we call this side little a and say a squared equals b squared plus c squared minus 2bc cos the angle in between. That kind of thing. So I won't go through that. There's a couple of ways of doing this. Alright, so that's FD. And of course DC is 30. It's the side of the equilateral triangle. So we add these two numbers to get the total distance travelled by the helicopter. And we have the speed of the helicopter. So speed, average speed, is distance travelled divided by time taken. So we're assuming that this is the average speed of the helicopter over the entire journey. Or maybe the helicopter flew with this constant speed. Well, that's not going to happen, of course, but we're assuming that this is the average speed for the entire journey journey of 81.96 kilometers. So the average speed is distance over time. So time is just distance over speed. Just interchange S and T. Okay, so the distance is in kilometers. The time is in what are we doing here? Yeah, the distance is in kilometers, the speed is in kilometers per hour, not the time. We're looking for the time. So the kilometers cancel. 80 divided by h is the same as we're multiplying the top by h, multiply above and below by h, so the answer comes out in hours. That's our unit of time. A lifeboat taking part in the search sailed in a straight line from the point K, that's the center of the circle, until it reached a point X, the midpoint of the line ED. Okay, so the lifeboat sailed from the point K until it reached the midpoint of the line ED. Okay, so here's the picture. Okay, the lifeboat went from K to the midpoint of the line ED. But since we're dealing with an isosceles triangle, since these two sides are the same, if we draw a line from this point to the midpoint of this side, this line here will be perpendicular to the line ED. Okay, you can prove that. That's provided that these two sides are the same. So we have a right angled triangle here. Now we know what this side is, it's 30. We have to get the distance of K to X. We know the distance of E to D is also 30. So the distance of X to D is 15. So we just use Pythagoras Theorem. So the square of the longest side, or the hypotenuse, 30 squared, is the sum of the squares of the two short sides. So this side here is got to be taking the square root of the longest side squared minus the other short side squared. Of course, that's not the only way that you could do this question. This angle in here, as we know, is 60 degrees, as in all the dotted triangles. So the side opposite 60 is what we're looking for. So sine 60 is the side opposite 60, which is kx, divided by the hypotenuse, which is 30. So kx is 30 times sine 60. That should give you 25.98. You could also look at this angle here. If this angle is 60 degrees, well, this angle in here is 30 degrees. 30 and 60 is 90. So what we're looking for is the side adjacent to the 30 degree angle. So the cos of 30 is the side adjacent to it, which is kx, that's what we're after, divided by the hypotenuse, which is 30. So we could multiply 30 by cos 30 to get our answer. Okay, we could also consider the tan of 30. Tan of 30 is the side opposite 30, which is 15, divided by the side adjacent to 30, which is kx. And if we multiply and rearrange, well, that's just the same as interchanging these. We get the distance of k to x is 15 divided by the tan of 30. So there's numerous ways that we can find kx. The buoy was located at the point where the path kx of the lifeboat crossed the path fd of the helicopter. How far was the buoy from x? Okay, so where the path kx crosses the path fd of the helicopter is this point here. So we want this distance. Well, we can work with this right angle triangle here. So what are the angles in this right angle triangle? Well, we don't know this angle, at least not yet. We could probably consider this angle here. Well, this angle added to the one next to it gives us 60 degrees, of course. This is not necessarily half a 60, by the way. Let's look at this triangle here. This angle here is 120 degrees. Now these two angles are the same. This angle is equal to this angle because we have an isosceles triangle in this triangle. Okay, so this is an isosceles triangle. So if this angle is 120, these angles must be 30 degrees each, which tells us straight away that this angle must be 30, because 30 and 30 gives us 60 in this dotted triangle. So this angle is 30 degrees, so we want the side opposite 30 degrees. So what we are given is the side adjacent to 30 degrees, so we want the ratio that brings in opposite and adjacent. Well, that's the tan of angle 30 degrees. It's opposite over adjacent. So y is 15 tan 30